Hello, welcome to the tutorial of web scraping using R. This particular tutorial focuses on how we can scrap a data over website for multiple links. This is Dinesh. Uh, Before I start my tutorial using R, I would like to take a few minutes on giving introduction about web scraping and why do we need it and why it is important. Web scraping is a technique for converting the unstructured format data like HTML tags over the website to structured format. Since the data over the website keeps on growing, nowadays web scraping has become a must-have skill for any people who are working on the field of data analytics. But the problem here is almost all of the data available over the website is not readily available. It is present in an unstructured format. Therefore, we need this technique called web scraping to convert it into a structured format, which can be easily accessed and used for further analysis. In this video, I'm going to take you through the process of web scraping in R. To get started with web scraping, you must have a working knowledge of R language. If you're just starting, you might have to brush up the basics of R. In this video, we'll be using RWest package and CSS Selector. I'm going to open a new script right here. I'm going to show this library RWest. So I've already installed in my system. If you have not installed this RWest package in your system, so you can install it by going to tools option and install package right here and type it RWest and click install here. Otherwise you can use install.package of RWest. Okay, the next thing that I'm going to use is a CSS selector. This CSS selector of any web page is used for finding the relevant field in a web HTML document. For example, in this tutorial I'm going to use Cochrane library for scraping. So if you go to this particular website and here the table of contents, you can find all the list of papers that are published in the year of 2017 with the issue 10 and all the authors, the DOI. So you can find the history of all the available papers right here, 2004, 2008, all the issues. So this CSS selector can be accessed using a selector gadget right here. So this selector gadget, you can get it from the selectorgadget.com. So if you go to the selectorgadget.com, you can find our try our new Chrome extension right here. So if you click on this, your browser will get added to this selectorgadget.com extension. So using that selector gadget, what you can do is you can just click on the selector gadget and click on any field of the particular HTML page and it will show you the CSS selector of that particular field. So you can just copy this CSS selector and use it in your code to scrap the data. The next thing that I'm going to use is the pur package called pur library PURR. So this package will help you to tackle the most common data manipulation challenges. This package has got a set of map functions for manipulating vectors. So okay, let us start the scripting part. So the first thing I need is a URL. I'm going to name it as a URL base, and so I'm just going to clear this. I'm going to copy this URL and paste it right here. So using map.df, which comes from the package pur, I'm going to loop it from the issue 1 to issue 4. So if you, I'm going to close this selector gadget. If you take the issue 2004, we have issue 1, 2, 3 and 4, and in each issues we have a list of the papers that are published by different authors and the publication date, the DOIs and the abstract, the PDF format, everything were available. So if you look at this particular URL right here, you can see it is of 2004 issue 4. If you click on issue 3, the issue get updated to issue 3. If you click on to issue 2, issue get updated to issue 2 and so on. So what I'm going to do is I'm going to loop from issue 1 to issue 4. That is I'm going to write it here, 1 to 4 function. I'm going to give the variable I here. The first thing I need is the web page. The web page can be accessed through read HTML, which comes from our west package. The next thing that I'm going to do here is I'm going to make this URL as a dynamic one. Here you can see only issue 4 is available, so you can make this 4 as the dynamic parameter and make this as using sprintf. You can concatenate URL base and I, so that you can every 1 to 4 the URL will get dynamically changed, and you can get the data from the web page, multiple links. So here I'm going to create a data frame from the list of all the data that I have scrapped, because the using data frame it will be easily accessible for the data analysis. So I'm going to create a data frame. So the first thing I need is a issue ID. I'm going to name it as a issue ID, and using HTML text from the harvest package, we have a function called HTML text. This HTML text will extract the tags text from the HTML document from the HTML node. So if you see, we have HTML node and HTML nodes. If you give HTML node, it will extract a single element from a HTML tag, and if you give HTML nodes, it will extract a list of elements. So I'm going to give HTML nodes and my web page, and I need the CSS selector. So I'm going to click the CSS selector and click here and copy this CSS selector right here and paste it here. Okay, so I also need other 3 variables, which is the second one is a heading of the paper. I'm going to name it as a heading, same HTML text, HTML nodes, and my web page. Can clear this selector gadget, and this is the heading of all the papers. And right click here and copy this particular heading and paste it here. The next thing I need is the author of that particular heading, HTML text, HTML nodes, page, and I need the CSS selector of the author. Clear this and click on the authors. You got the CSS selector, right click, copy here and paste it here. Finally I need the DOI. DOI is a unique identifier of this particular paper. So HTML text, HTML nodes, web page, and I need the CSS selector of this DOI. Click on this DOI and you got the CSS selector. Copy it and paste it right here. So finally we are going to name this data frame as Cochrane 2004. Okay, so let's run this code. Okay, we got Cochrane 2004 issue 1, heading author, device, issue 3, you can find issue 2 right here, issue 2, issue 4. It has perfectly scrapped the data, but we have some warnings right here. Let us look at it. Warnings. Okay, so unequal factor levels. Okay, this can be avoided by giving string as factors as equal to false, and let us also give some process indicator here so that you might know that the code is perfectly scrapping. Code is scrapping. Perfect. So we got the issue ID, the heading, and author of all the heading, all the papers, and the DOI of the particular paper. So this has scrapped for multiple links dynamically. Thanks for watching this tutorial. I hope it will be useful, and share your comments in the video below. Thank you.